Hello! In this video, I'm going to show you how to perform a one proportion hypothesis test using an Excel calculator developed for this course. You can download the Excel file in the comments below. I believe there are a lot of vegetarians in Portland, Oregon. I live here in Portland, and every restaurant seems to have a few good vegetarian options. I think that's because there's just more vegetarians who live here. I did a quick Google search and found a Pew poll that said 3% of Americans identify as vegetarian. And then I took a random sample of 200 people living in Portland and found that 18 of those people were vegetarian. Let's test at an alpha equals 1% level the claim that the proportion of vegetarians living in Portland is higher than the national rate. Let's set up this test. The first thing we always check is the assumptions. We always need a random sample. And we have that random sample of 200 people. Then we need to check our situation. A test for a single proportion is appropriate when you have one categorical variable. Our categorical variable in this case is vegetarian. Are you vegetarian or not? Lastly, the sample size needs to be big enough for the central limit theorem to make the sampling distribution behavior of the proportion become a normal bell curve. So is it big enough to get that bell curve behavior? And that condition is n times p being greater than or equal to 15. In this case, n is 200 and p is 3%, so n times p is 6. That is too small to meet our condition. This is sometimes the case. For the sake of class, we will continue on with this example. In the real world, we would either try to gather a larger sample, or we would look for a method that is less bound by that condition, n times p is greater than or equal to 15. First, you've got to let the reader know what our parameter is in this special circumstance. This case, the proportion we're measuring is the proportion of vegetarians of people who live in Portland. So let P represent the proportion of Portlanders who are vegetarian. Then we would say our null hypothesis, H sub 0, is our proportion is equal to 3%, the national average, and our alternative, H sub 1, is that proportion is in fact greater than the national average of 3%. The claim always goes in the alternative. Tests have the power to reject the null. Rejecting the null is supporting the alternative. We'll reject the null when the p-value is smaller than our alpha level. So let's calculate the numbers and see what we get. Here is the Excel calculator developed by my colleague Nadeshani Janyasana. And in this calculator, you change the values in green, then the values in bold black are your result. We need to enter the number of successes. There were 18 people who are vegetarian in this sample. Then the sample size, we sampled 200 Portlanders randomly. And the claimed value, 3%. Here we are. Looking at our result, the sample proportion p hat is 9%. That's promising, that's more than 3%. Standard error is a little more than 1%. The z-test statistic, it's like the z-score of how far away, the number of standard deviations our sample value is from the hypothesized value. and that is 4, nearly 5. P-value for a one-tail test, 0. And p-value to a two-tail test, 0, going out to 4 decimal places. Which type of test were we doing in this situation? The alternative is which tells you whether you're doing a one-tail test or a two-tail test. Here, the alternative is greater than, so we're doing a one-tail test. Great. Looking at this conclusion, p-value is less than alpha. So we reject the null hypothesis. And always go on to tell the reader what that means in this context. What is the null hypothesis this time? That the proportion of vegetarians in Portland was the same as the national proportion. We reject this, and that means there is statistically significant evidence that the proportion of vegetarians in Portland is greater than the national average. Is greater than the national proportion. Nice. What's the chance that my answer is wrong? I know every sample is different, so I could have just gotten a really unusual sample of Portlanders. I rejected the null hypothesis. So rejecting the null hypothesis when you should not reject the null hypothesis is a type 1 error. And we set the upper bound of type 1 error to 1%. Okay, I've set the alpha level really low, so I'm feeling pretty good about my conclusion that the proportion of vegetarians is greater in Portland than compared to the rest of the nation. In our test, we concluded that there was statistically significant evidence to support the claim that the proportion of vegetarians in Portland is greater than the proportion of vegetarians in the nation in general. But how much greater? A hypothesis test can only answer the yes or no question. Can we support the claim? Yes or no. To know how much we support the claim, to have an estimate of possible values the proportion of vegetarians in Portland could really be, we need to follow up with a confidence interval. See my next video to conduct a confidence interval for this example using the Excel calculator generated for this course. Happy studies!